What we're going to do now is we're going to talk about a certain type of CompletableFuture method, which is used to handle runtime exceptions. And you can either think of these as being sort of part of completion stage methods that handle exceptions, or as I like to do, you can think of them as their own category of CompletableFuture methods. So I like to think about them as their own category because I think it makes it easier to understand, and their semantics are a little different from the completion stage methods we just talked about. So these are the exception methods, and we'll start by giving an overview of the exception methods, and then we'll talk about how to apply them in practice. So as you might expect, exception handling for asynchronous computations is more complicated than for synchronous computations. Why is that? Well, if you have synchronous computations, the kind of stuff we've grown up with pretty much from programming with Java or C++, they work very easily and very intuitively. What happens is if an exceptional condition is detected and an exception is thrown, then that exception just propagates back up the runtime call stack until somebody finally handles it, or it falls off the top of the thread, in which case you get an unhandled exception error. So if some call deep down in a chain of method calls throws an exception like IO exception, then the Java runtime environment will start searching back up the call stack to find the appropriate exception handler to handle that call. And then at some point, hopefully somebody will catch the exception or things fall off the top of the thread, which has its own consequences. But let's pretend like somebody catches the exception. But the whole point there is this whole thing is done synchronously. Completable futures, however, that run asynchronously don't conform to the conventional call stack model. And that's because the completion stage methods will typically be running in different worker threads than the thread that initially invoked them. And the thread that initially invoked them may be off doing something completely different by the time an exception occurs. So returning that exception back to the caller, the original calling thread, the one that made the call, isn't going to be very useful because that thread's probably off doing something completely different, because that's the whole point of asynchrony, is not to wait around for the results to finish synchronously. So therefore, we have these completion stage methods that handle runtime exceptions that can occur in an asynchronous way. And there are three of these, and then there are different combinations of these. I'm going to first talk about what's in Java 8, and then we'll talk about some enhancements that were added later in later versions of Java. So there are three of these methods. One is called whenComplete, and that takes a by consumer, and that returns a completable future with a result of either the earlier stage, if all went well, or the exception if things go awry. So what this will do is it'll handle the outcome of a stage, whether it's a result value or an exception. And whenComplete is kind of an interesting case because it doesn't really interfere with any exceptions. It just gives you a way to deal with them if they occur. If you want to actually handle them, however, there's another method called handle, and that takes a by function. And that by function is going to be called differentially depending on whether or not you got a normal result or an exception result. And so we'll see how handle can be used. And then the third and final type of exception method in this grouping is called exceptionally, which is kind of a funny name. And that takes a function, and when the exception occurs, you can replace the exception with some result value. So this is really used to keep the computation going. Even if something went wrong, you can still get back a result, and you can still have other processing occur on that result. So the whole point of these methods, naturally, is to make your program more resilient by handling error and error computations, erroneous computations, in a more graceful manner. You'll also notice that there's the async and non-async variants of these. There was also another method called exceptionally async that was added in Java 12. So this does not come out of the box with Java 8, but if you're programming with Java 12, then you can get exceptionally async. And this is important for our class because Android, as you probably recall, only supports up to Java 8. So exceptionally async is not part of the Android API. So that's just a quick overview of the different types of methods that you have that handle exceptions in completable futures. What we're going to do next, of course, is actually look at some code examples to illustrate how to apply these methods in practice.